All right, so our real number system, which is pretty much every number that you have ever dealt with yet. It's composed of what we call rational and irrational numbers. So I found this little graphic down below to help us figure out the real number system. Now, again, no number that you've dealt with has ever been not real. There's only one kind of number that's not real, and you'll learn about that in Algebra 2, not now. So all of these are real numbers. This circle over here, this presents what we call our rationals. And as you can see, the rationals even have different number systems within it also. So one number can have multiple different kinds of names that go along with it. So going to the innermost one, right here, this circle. 1, 2, 3, 4, 5, 6, 7, 8, dot, dot, dot. That's what we call our natural numbers, because when you are young and you start learning numbers and you start learning to count, what number do you naturally start counting with? 1. You get the little book. 1 yellow ducky, 2 yellow duckies, 3 yellow duckies. So it's just natural. You start at 1 and you just go up from there. So then just outside of your natural numbers are what we call our whole numbers. So your whole numbers are all of the naturals also. So 1 is both a natural number and it's a whole number. Same thing with 2, 3, 4. Whole numbers just also now add that number 0 into it. So 0 is also a whole number. It is not a natural number though. So then just outside of your whole numbers are what we call the integers. So that just brings in the negative versions of your numbers. So -1, -2, -3. And then those are all also in your rational numbers. So rationals also just bring in your fractions, decimals that terminate. So for example, 0.5 is a rational because it is a decimal that terminates. Decimals that repeat patterns. So for example, 0.3 repeating would be rational. So the majority of numbers that you've dealt with so far are actually rational numbers. So for example, as I was saying, numbers can fall under more than one category. If I have, for example, the number 4, that is a natural number. As you can see, it's right here in the natural circle. It is also a whole number. It is an integer. It is rational. And it's a real number. So any one of those categories can be used to describe that number 4. It falls within all of them. It's not just a one thing. Over here in the other bubble, those represent our irrational numbers. They are in no way related to your rationals. They are completely separate. They are the square roots of non-perfect squares. They go on forever. There's no pattern in your decimals. Your decimals never end. Our most famous irrational number would be pi. Continues on forever. No pattern. Doesn't end. So that's what our irrational numbers are. So you got rational and irrational. Now you do need to know these different systems because a lot of times they like to ask us questions and they talk about the rationals or they talk about the integers. So you got to remember what the difference is between them. So let's take a look at our examples we have down here. Which expression results in a rational number? All right, so we're trying to find a rational number. So let's start with what they gave us as choices. Let's identify those. So L, the square root of 2, is that going to be rational or irrational? Irrational. It's the square root of square root of 2, so that is irrational. How about 3 radical 3? Is that going to be rational or irrational? And it's going to be irrational because that radical 3 there, that's going to make non-ending, non-repeating decimal. How about the square root of 16? Rational, because what does square root of 16 equal? 4, so that's rational. And the square root of 9 is? So that makes it rational. So whenever you're adding, if you want a rational number as your answer, you have to add the 2 rational numbers together. Anytime you add anything that includes at least one irrational, it's not going to be a rational. So which of our choices is the rational plus the rational? 3. This 3 is n plus p. So rational plus rational gives us a rational. This one is both irrational, so that's not working. This one has 1. That one has 1. Anytime it's one of them is irrational, when you're adding, it's always going to be irrational. D is an odd integer and E is an even integer. Which of the following is an odd integer? So for these ones, what I find works best is let's pick an odd integer for D to B. Let's just pick any odd integer. Keep it small though. 1. So now let's pick an even one for E to B. 2. So anywhere I see a D, I'm going to put a 1. Anywhere I see an E, I'm going to put a 2, and I'm going to see which one gives me an odd number as my answer. So first one, 2 times 1 plus 2, what does that give us? 4. Is that odd? Nope, so it's not that one. So we'll try choice 2. 2 times 1 plus 2 times 2. 2 plus 4, 6. So no, not that one. Let's try choice 3. 1 times 2 plus 1. 3. So it's looking like it's that one, but I always like to check my last choice, just to be safe. So 3 times 2 plus 3 times 1 plus 1. It gives me 6 plus 3, 9 plus 1 is 10. So yeah, nope. And what's the third one? And so in our last example, something like this, if A does not equal B, and A and B are prime numbers greater than 2, which of the following expressions must represent an odd integer? So we're still trying to get an odd integer answer. Here's a little vocab thing. What are prime numbers? Not even, no. 7 is an example of a prime number, yeah. 11 is, yeah. 2 factors. 1 and then the number itself. So for example, 2 is a prime number because the only way you can get a 2 is 1 times 2. 2 factors, no other way. 3 is a prime number because it's 1 times 3. And that's it. Is 4 prime? No, because you can do 2 times 2, so it's got more factors. 5 would be prime, 7 prime, 11 prime, so we've only got 2 factors. The one that people get confused, 1 doesn't fall under that categories, because what do we multiply to give us a 1? 1 times 1. It's the same number, so it has 1 factor. Prime numbers have to have 2 factors. That's only got 1. So that's why it starts at 2. So again, A and B are prime numbers greater than 2. So I'm going to say A is a 3, and I'm going to pick B to be 5. I'm going to pick my smaller ones, because then it keeps my numbers smaller. So let's look at my first choice. 3 plus 5 minus 2. 6. That's not an odd number, so it's not that one. 3 times 5 minus 1. So, no, that's not it. 14 is not odd. 3 times 5 plus 1. 16, so nope. 3 times 5 plus 2. 17. There's my winner. Looking for the odd number. Finally got it. So these kinds of problems actually pick numbers that fit those situations and try them. Test them out. See if it works. All right. Let's go into our properties. These words look familiar, hopefully. Commutative, associative, identity, inverse, distributive. So commutative is our change order, meaning no matter which way you add two numbers, it's going to give you the same answer. 3 plus 4 is 7. 4 plus 3 is still 7, so changing those orders don't matter. Same thing with multiplying them. 3 times 4 is 12, just like 4 times 3 is 12. So order for adding and multiplying does not matter. Associative is our grouping property. So that just says any way you choose to group them, you will still get the same answer. So 2 plus 3 plus 4 gives you 9. Just like 2 plus 3 plus 4 also still gives you 9. So no matter which way you group them, you still get the same answer. Again, same thing with multiplying. So whether you group and multiply the 3 and the 4 first, then times 2 you get 24. Or group 2 and 3, you get 6 times 4 is 24, you still get 24. But they only work for adding and multiplying, does not work for subtraction or division. I like to put stars on identity and inverse because these are the ones that people kind of tend to get confused most. So your identity is what gives you the number back, and that'll make sense when I give my examples. So for addition, what number when added to 3 would give me a 3 still? 0. So what we say is 0 is the identity element. And that's only for addition. 0 is the identity element for addition, because if you add anything to 0, you're going to get that same thing back. I could add negative 20 to 0, and I still get negative 20. So then for multiplication, 4 times what gives me a 4? 1, so that means that for multiplication's sake, 1 is the identity element. You can multiply anything times 1, you get that same thing back. So then for inverse, opposites is kind of a good way to think about it. So for the inverse, you're looking to get the identity element as the answer. So if I'm doing my 3, I want 0 to be the answer. So what would I add to 3 to make it a 0? Negative 3. So 3 and negative 3 are inverses. Because when you add them together, you get 0, which is the addition identity element. Now I find multiplication is the one that's a little trickier. So 6 times what would give me my identity of 1? If I do it times negative 5, though, that'd give me a negative 30. So let's think about it. Do you guys remember what every whole number is always over, but we don't write it? 1. It's what I like to call my invisible math. So this 6 is really over a 1. It's just we don't write it every single time because, let's face it, we get lazy sometimes. So for multiplication, the inverse is you flip it. So it'd be 1 over 6. So then when you multiplied, 6 times 1 would give you a 6 over 6, which reduces to 1. And then our last one, distributive. Most people are good with distributive in this form. If I have A parentheses B plus C, we would take that A and we would distribute it and multiply. So I would get AB plus AC. The one that's a little lesser known but is still very important because we will be using it a lot throughout the year is distributive property also works if you're dividing. So if I'm dividing B plus C by A, that's the same as doing B divided by A and then adding to it C divided by A. So distributive property also works in that division context also. I mean, I'm doing the same thing here. I was just multiplying. That was multiplication here. I'm going to be dividing each one by both. So what I want you to do is take a couple minutes, fill in which property is being demonstrated on the left. Fill it in on the right. Fill line over here on the right. All right, you guys got those all right. Question? All right, we got 2 more problems to do on the next page. Wow. Tell me how you really feel. All right, so in these kinds of problems, what we're doing is they've already done out all of the work to get from the start to the answer. We just have to identify what property allowed them to do what it is that they did. So starting with letter A, left side of the equal sign, what did they do to get over here to the right side? Distributive. They multiplied that 3 through the parentheses, so they did the distributive property there. So now we're just going to be going down. So what changed from here to here, and what property let them do that? They switched them. Which one is the switching? Commutative. I always like to remember it. Commutative stands for change order. That's another way you can go. So both starts with CO, change order. Commutative. All right. What did they do from B to C? They added parentheses, which means they grouped something together, so they did the associative. Whenever you group things together, that is your associative. All right, then this one is really tricky. C to D. I'm like the first person to actually get it. Yes, it's distributive property, but it's backwards. We're used to seeing distributive property go from this line, and then you would distribute your C through, and you would get that line up there, but they were just going backwards and taking the C away. So it's still the distributive property, but instead of multiplying through, they're just taking it away. So it's the backwards one. All right. Number 2, same thing again. So we're just going to move down from line to line to line to figure out what they did. So yeah, first one was distributive. That one's easier. Yep, and then we got commutative. They switched the 12 and that negative 5x. What did you say? Distributive, backwards distributive. Instead of giving them the x like we would normally see here, they took the x away. They took it away. They went backwards. So remember, normally we would see it this way first, and you would multiply x through, giving you the 3x minus 5, but instead they went backwards. They both had the x, and then they took the x away, so you just have 3 minus 5 in there. That one is tricky. We'll keep practicing that. All right, now the next one, it's not really a property. What did they actually do? They simplify. They actually subtracted 3 minus 5 to give them a negative 2. We subtracted those, we got -2, so that's just to simplify. Then what do they do? Are those in the same order? Commutative. It was x -2, but now it's -2x. They changed the order. Very subtle, but still, they did it. And then the last thing they did is another simplify, because they actually added 12 and 10 to give us 22 something. It's just purely a simplify there.